Do you know the days of the Advent? So there is this website called adventofcode where they give you a exercise for every day of the Advent, and you can solve it and get 1 star if you solve part 1 and 2 stars if you solve both part 1 and part 2. And it's now running by a full week, and I've participated for all of this week to see if 42 can handle those problems or if I found any serious issues. The first exercise for day number 1 is called Sonar Sweep. There is quite a lot of text that you can go to read if you want, but the idea is that in all of those exercises we receive an input that is just a text file, and they give you an example of this input, so here with those numbers, and then they give you a description of what to do, and you always have to get a number out that you have to provide as an answer. And so here, for example, we have to check how many times following this list of numbers we get some increased value. And then for a part number 2, we don't want to just look to the individual number, we want to make a window of numbers. So we want to check for the first 3 numbers if their sum is less than the sum of the 3 numbers keeping the first one, and for the 3 numbers keeping the first one we want to check if it's less than the 3 numbers keeping the second one too, and so on. How do we solve this in 42? Well, first and foremost we import the file system library. Then we have a static method part 1 that takes an input, the mutable file system library, and reads the file provided from the website into a string that we call input. Then we want for part 1 to just found whenever the value increases. So we have the last value that at the start is just max index, and then we call match.count. Match is a very useful class that have a bunch of nested classes like count, any, all, sum. And the idea is that we first create a counter object, and then we pass to this counter object the void result of this for, and thanks to the slash we are able to talk about the count object so we can grow the value, and then the count object return the accumulated result. So here, for example, we check for all the string into input.split on new line. And what this is doing, this is taking the strings one after the other from this big input string, checking for new lines to separate them. And then we convert the string into an index, and then if the index is bigger than last, we add this index. What it means? It means that if this value is true, we will get the +1 on our count, and if this value is false, we will do nothing on our current count. And that's it, that's our part 1. You can run it by doing main part 1 of debug of part 1, where we pass the file system. And to create the file system object that is a capability object and can actually interact with the file system, we need to use the $. And the idea is that only the main can use the $, so that we are certain that if a piece of code doesn't receive a capability object, it's not going to be able to create one from scratch. Moving on to part 2, to make the window, since this is just a window of 3 elements, the easiest way was just to make a class with 3 fields, A, B, and C. And then the total is going to be A plus B plus C. And then when we read a new number, we are going to push all the numbers down, and the number in A is going to be flushed away from our window, and the number in B is going to end up in A, and the number in C is going to end up in B, and finally the new number is going to be saved in C. To read the data from our window, we can just read our input file, and then make again a match count, where for all R in range.unbounded And for all s in input.split on new line, we do something. So we understand this part. This is just all of the string followed by new lines. And this is just a range that never stops. So it's going to keep counting 0, 1, 2, 3, 4, 5. But it's also not wanting to actually reach up to infinity. So when this sequence is over, also the infinite range is going to terminate without an arrow. And we use the infinite range because we want to sort of skip the first 3 elements. As you can see at the start, we just need to fill up our window. So we don't need to check if there is any change in our measurement yet. When our window is full, we can just take the result of tot from this, and then we push the new number that we have read, and then we take tot again. And so now we have the difference between what was before and what is now. And then we can just add a value to our count if tot1 is bigger than tot0. And then we can just call our main part 2 exactly as we did for part 1. In day 2, we are driving a submarine. And part 1 is quite trivial, so we are just going to jump to part 2. The idea is that the submarine can follow a set of commands. Can go forward, can go down, can go up. And in part 2, the submarine, when you ask to go down or up, is going to basically point down or point up. And when you ask it to go forward, it will go forward over a certain amount, and then depending on how much it's going to point up and down in that moment, is also going to go more in the depth of the ocean or more up toward the surface. So the idea is that we have those kind of commands like forward 5, down 5, forward 8, up 3, and we will need to somehow parse those commands, because we will get a file look like this, and move our submarine according to those commands. Then in order to get a result, because the puzzle wants a result, we just have to multiply the horizontal position by the final depth. To solve day 2 in 42, we of course import the file system library again, and then we have a trait. And the idea is that we want to make 3 different classes for the 3 different kinds of commands, but those classes are going to be very, very similar. The only thing that changes is the string that identifies the command. So following the programming pattern called template method pattern, we can make those 3 classes by reusing the code. So in particular, we have a field val that represents how much we are doing it. We are moving forward 5. Val is going to be 5. And then we have this class method string name. This is the whole, the part that we have to provide in order to complete the code. And then we have a method fits that returns a boolean, and again is a class method. It checks if a certain string starts with the name. So if we give the command forward space 5, this will start with forward. So that command will fit this this particular type. And then we can have a factory where we take a string, and from the string we extract the number. And how do we extract the number? Well, we have the name, we have the length of the name, we add 1 for the space after the name, and then we go from there to the end of the string, and we take the substring, and that's the extracted number that we just have to parse as a number. And then we just call our predefined factory to create our object. And then we can make forward, down, and up by calling the process trait, adding the information for what is our name, and then turning the resulting trait into a class. We can now have a submarine. This is going to be a data class with 3 fields, 1 for the aim, 1 for the depth, and 1 for the forward. And then we can have a method process command that process commands. And then for the 3 commands we can check if down fits the command. We set our aim to be more down, depending on how big is the value of the down command. If it's up, we set our aim up in function on how much the command sets our aim up. And if it's forward, we create a forward command, we extract the value, and then we add to forward the value. So this is basically forward plus equal val in most languages, but this is a field, so this is calling the setter. And for the depth, we use the current depth plus the aim multiplied by the value. And that's it. That's our exercise. We just make our object capability, we read the input, we create the submarine, and then for all the comments in our input, the submarine will process the comment. Oh, so day 3 was quite challenging and not very engaging, I have to say. And it was about having a big sequence of binary numbers and then applying some kind of filtering and reasoning in order to extract values. So the first values was called gamma and epsilon, and the second two values were called oxygen generator rating and CO2 scrubber rating. Okay, so the idea is that for the first two values we have to check which of some bit was the most common, while for the second pair of values we had to make a filter and filter the binary numbers until we was left with only one. To solve day number 3, I made a couple of static methods. So POW2 is computing the power of 2 of a certain index. So if the index is 0, we just return 1. Otherwise, we get 2 multiplied by the recursive call of ourselves of that minus 1. And then I have a method that checks if it is 1 for a string in a certain index. So we have a binary string that is a string of 0s and 1. We have a position, and if the string starts with exactly the character 1, starting looking in the offset of the index, we say yes, this is representing the 1 binary number. So in this exercise we had a bunch of binary number of length 12 bits. So I made this list tot with a bunch of zeros at the start, and then I have no idea how many binary numbers I have, so I have size equals 0, and then for all the lines in our input, size plus equal 1, so I'm counting the input while I go, and then for var element in tot and index in range of tot.size, we check if it is 1, the string in index I, then we do e plus equal 1. Now, this is a multi-for that is iterating on two things at the same time. So we are iterating on the elements in tot and on the indexes of tot. So while this is going to go from 0 to 11, this is going to point to the actual value corresponding to the index from 0 to 11. And this is in var mode. So we can add +1 to the element when we found that the corresponding string have 1 in that point. What are we doing here? We are counting for each of the bit how many times there is a 1. And then we have our gamma and epsilon number for all the counting, so for all the amount of 1 bits in the various position, and for the index in the range but reverse. So we start with 11, then 10, 9, up to 10, so that the most meaningful binary bit actually have the bigger index. In the exercise, we have to find if a certain binary bit is most often 1 or most often 0. We have counted how many bits have number 1, and we know how many lines we have. So if the number of 1 multiplied by 2 is more than the size, we know that most of them are 1. And so the corresponding bit in gamma have to be set to 1. Now, we could first compose gamma as a binary number and then convert it into decimal. But there is absolutely no reason to do that. We can just add the corresponding decimal number to gamma directly here. And otherwise, we have to add this number to epsilon, because that's the exercise, pretty meaningless. To solve part 2 instead, we need to take this big list of binary numbers and filter it until we get one single binary number, and that's our answer. So to solve this, I start by just making the list of all those binary numbers as a list of strings, and then we have this method called to1 that take our list of string and turn it into a single string that is going to be our result. And finally, we parse this binary string into an actual decimal number. There are actually two different ways to collapse the strings to 1 to compute those two very weirdly named other parameters that we need to obtain to solve this puzzle. Those two ways are very, very similar, and so I'm just passing a Boolean parameter to select between one or the other. So first, we check how many bits we have. 12. I could have just write 12 here, but yeah, it's this way the code is more parametric. Then, how many values are remaining? We need to get down to 1, but for now we have that.size. And then, forever while counting how many steps we have done, so starting from 0, 1, 2, and so on. If the remaining is exactly 1, well, we are sorted. We just need to return that one. And how do we return it? Well, the idea is that we are mutating this list that we take an input, and we are putting an empty string whenever we select out one option. For all the strings in the list of the strings, if the string is not empty, that's the only remaining string, and so we can return it. Otherwise, we have our match count again, where we check for all the strings that are not empty, so that they are still in play. We have to count this if it's a 1 in the string that we are looking for in the index I. That is, this unbounded will only probably go from 0 to 11. Then here in line 40 is where we switch between the two different criteriums. We need to check if the number of bits on 1 on the remaining strings is more or less than the remaining. If it's more, and we are in the first case, we seek a 1. Otherwise, we seek a 0, so we don't seek a 1. So this will be false. And then, for all the string in the list, in var mode, so that we can set them to empty string in order to remove them. If the string is not empty and the seek1 is different from is1 in S of index, so if what you seek is what you get, then we leave it. If what we seek is not what we get, we eliminate it from the group. And we set that there is one string less remaining. Now, the type system of 42 recognizes that we have a 4 that could potentially finish, because in the type system there is no information about the behavior of unbounded, of course. And so we have to manually convince the system that this code is unreachable. And here we just parse our string as a binary number. So we start from 0, we take the number of bits as a range, then we take the number of bits in the reverse order, so that the most powerful one, the most influential ones, have the bigger number. And then if we have a 1 in the index I, we sum to res I plus equal po2 of j. And that's doing the conversion. And finally, we just make up a main that call our code to give us our 2 extra numbers. Now, day number 4 was about bingo. And since I don't want to torture you, I'm not going to show you the day of bingo. You can look in the video description and there is the link of my solution for the bingo. On the other side, days number 5, 6, and 7 were pretty cool. So, day number 5 was about hydrothermal vents. That is, basically there are lines and we want to see where the lines intersect. And in the first part, we just have to check for horizontal and vertical lines. In the second part, we also have the diagonal lines. So I'm going to show you just the solution for the diagonal lines. The idea is that we have this file where we have a bunch of lines. So this one goes from the point 09 to the point 59. This one goes from the point 80 to the point 08, and so on. For our points and line exercise, we will define our point class. We will add a list of points inside our point class. We will have a coordinate x and a coordinate y. And then, since we are parsing stuff, we are making a method that parses our points from strings. And so this is a class method that returns this point and take an s string. It's convention in 42 to have those methods that take a single parameter called string, where we are parsing the value from a string. Then we take our string, we split it on the comma, and so we get our point as a splitterator. And then we just make a point where x is the integer representation of the first element, and this is, reading the first element from the splitterator and going next. And then for the y, we read the next element of the splitterator and we turn it into an integer. And then we have a map from points to indexes. And then we make our line class that, as for the point class, it has 2 fields and we add the list of lines inside. And then, as for the point class, since we want to parse this stuff, we have a class method, this as string. And this time, we split on the arrow. And if you look carefully, we also have a space before and after the arrow. And then again, exactly as we've done for the point, we pass the first element of our splitted string to the first point and the second element to the second point. We then want to expand our line into a list of all the points that pass through that line. And we could think just to use a range to iterate, but actually you can have that sometime you start from low and then you have to go up, but sometimes you have to start from up and then you have to go low. And so if you just call the range, you may start trying to do a range from 10 to 5, and that will not really work. So I'm defining this error that returns the right range. So we pass 2 values, that and 2, and if that is smaller than 2, we just get the range from that to 2 up to 2 plus 1. We have the plus 1 because both points are included in our range, and so while the normal range will go from the first one included to the last one excluded, here we just add 1 to include both parts. If instead 2 is bigger than that, we go from 2 to that plus 1 in reverse. And that is fundamental when we compute the diagonal lines, because otherwise, instead of doing the proper diagonal line, we may end up following this one. And now that we have our R, we can make the expand. We extract coordinate x1 and y1 and x2 and y2 from point 1 and point 2. And then if x1 is equal to x2, we have an horizontal line. And so we just check the y to be going from y1 to y2, and we add our points. On the opposite, if y1 is equal to y2, then we have the other kind of line, and we modify x while keeping y constant. If we have a diagonal line, again, our multiple 4 works very well. we just go on the two ranges and we add all the points on the right diagonal. Finally, since we want to sort of print those points on this, discrete screen, we will make an expand in method that takes a mutable map and writes the point that have been expanded on the map. And how do we do it? Well, we do for all the point in the expanded point of ourselves, we extract from the map using as key the current point a value, and the map can have no value, so this is an optional. So if the optional is present, it means that there was already a point there, so we put in the map in the same position the value, the number that was already there, plus 1. If instead there was no point in that place in the map yet, we add the first entry at 1, so that we count that there is 1 point there. The main for main 5 part 2 is pretty standard. We have our file system capability object, we read our input, we parse our input in lines. As you can see, we just split over the new lines that give us the string representation of each line, and then we can parse our line from the string and we add it to the list that we are making, and in this way we have all our lines. We then make our map, and for all the lines in the list of lines, we expand the line in the map. Finally, since the exercise is asking us how many points have more than one line intersecting, we just explore our map, and for all the values, we count it if the value is bigger than 1. Here I forgot to delete them. You have my solution for part 1 and my solution for part 2. Day 6 was also quite interesting. It was about the exponential multiplication of lanternfishes. Basically, the system gives you a very inefficient but very easy to follow algorithms to make your lanternfish multiplies, and the idea is that those lanternfish have a number, that is how long before they will spawn a new lanternfish, and every day this number goes down by 1, and when it reaches 0, a new lanternfish is spawned with a timer of 8, while the current lanternfish go back to the time of 6. And as usual, we get a file that have a bunch of ages of lanternfishes. Is that the plural of lanternfish? And we then have to compute how many lanternfish there will be after 256 days. And the trick is that if you follow the algorithm originally proposed by the quiz, you will basically never be able to complete this puzzle. It will take an exceptionally long amount of time. Plus, the solution actually don't fit an in32-bit, so you will have to use some kind of higher precision number. In 42, we can use num as our very good super high precision number. We have the solution here for the first version of the algorithm. That is pretty trivial. We have our class day that take the mutable list of the ages of those lanternfishes, and we want to iterate over all the lanternfishes. But while we iterate, some of those lanternfishes may reproduce, thus growing the list. And we want to avoid iterating over those new lanternfishes too. So we limit our iteration to the current size of the list. So the idea is that if the lanternfish is of any age but 0, we just reduce the age by 1 point. If the lanternfish is of age 0, then this lanternfish will go of age 6, and we will add a new lanternfish at the end with age 8. And then we just repeat the same operation for as many rounds as we need. And this solution works for a reasonably small numbers of rounds. But if we want to grow this over a much higher number of days, since these lanternfish grow exponentially, we don't want to have a list with all the lanternfish represented individually. So the crucial idea is that every lanternfish is only distinguished by its age. So if we have two lanternfishes with the same age, we could very well just represent it as a single thing. So we can just have a list with as many spots as the possible ages of our lanternfishes, and with the number storing how many lanternfishes of that age are present today. So we can have our day 2 for our part 2 with a mute list of number called vals, the start with all zeros, and then we have a day. And to process a day, we take the leftmost value, that is how many lanternfishes have age 0, because you see, age 0, age 1, age 2, age 3, age 4, 5, 6, 7, 8. So how many lanternfishes have age 0? Then for the indexes from 0 to size -1, and for all the elements in our list of vals, starting from 1 and reaching the size, we set in the list the position I as the value E. That is, all the numbers are moving back. They are moving left one step. And then what happens is that all our lanternfishes of age 0 now go back to have age 6. So we update the number of lanternfishes with age 6, and we sum the number of lanternfishes that used to have age 0. And then the number of lanternfishes of age 8 is just the one spawned by the one of age 0. And then we have this funky code here, where in order to repeat this operation of day for a number of rounds, we can just say for e in range of rounds /day. Because remember, this is just equivalent of this dot day. And then the puzzle asks us to count how many lanternfishes we have in total. So to count the total, we start from 0, and then for all the possible ages, we see how many lanternfishes there are of that age, and we sum them all. So the main just reads the input, makes a day 2, splits the input over the comma, computes all the ages, and initialize the day vals. That is, if we see a lanternfish of a certain age, we just add 1 to the number of lanternfishes of that age. Then we can print how many lanternfishes we had at the start, that is 300 in my case. We process 256 rounds, and we get the number of lanternfishes, and then that is millions, billions, 1,695,929,023,803. That is way bigger than an int32-bit. Day number 7, that I've completed a few hours ago, is called the Treachery of Whales. And the idea is that there is the big whales that want to eat you, and a bunch of little crabs in their crab submarines that have to get all aligned together in order to shoot a hole into a cave system and distract the whale. To solve this exercise, you have to compute how much fuel the crab needs in order to get all together. And so the idea is that you have to find the right point where it's the most convenient for all the crabs to get together, and then you have to make all of those crabs move there, and moving there costs them fuel, and you have to compute how much fuel they are spending if they found the best point to come together. In part 1, the fuel consumption is linear, so the algorithm is pretty fast. But the fuel consumption in part 2 is more involved, and so if you simply follow the algorithm step by step, you will again get something that is way too long to compute. In particular, the idea is that the first step costs 1, the second step costs 2, the third step costs 3, and so on. To solve this in 42, I started making a bunch of static methods, one that compute the max from a list, one that compute the min from the list, and yes, maybe there should be something in the standard library to get those very simple computations instead of having to do them ourselves. And then we have a fuel class. And the fuel class is computing how much it costs for the crab to move. In this explanation, I'm going to skip part 1 and go directly to part 2, where the fuel consumption is more involved. And I started trying to just compute the fuel directly, and it just will have never finished. And then I remember that in 42 I have caching, and probably while I search for all the possible ways for the crab to come together, there are going to be so many different cases where I'm going to try to recompute the fuel again for the same distance, to cover the same distance, and that will have the same fuel consumption, because the fuel consumption is just in function of the distance. To encode this with cache lazy, I will do like this. I will have a class method that goes from num to num and calls the cached computation. So creates the computation object this, passing this the distance and round 1 as the field, and then calling the cache lazy method. And the cache lazy method, again, is just calling a method that is doing the computation by taking the distance and the round. This code is terrible. Let me fix it. So, yes, I need the distance. No, I don't need the round. Here it is. So, as we were saying, the computation object just needs to have the information of what is needed to do the computation, that is, the distance. And then we take the distance field, we have our default value for the round that will start from 1, and we can compute the distance. That is, if the distance is 0, we just return 0 the distance. If the distance is 1, we just return for how many rounds we have been moving. And if the distance is bigger than 1, we do round plus the recursive call on the result, where dist is this minus 1, and round is round plus 1. Now, yes, I discovered as a later stage that I could ignore all of this code and just use the formula that the mathematicians have found for these simple mathematical problems long ago, and that I've probably studied in high school, and I was just unable to connect while doing this exercise. So, still, thanks to caching, even with the slow algorithm, we get a computation that can actually be performed in a reasonable amount of time. So we have to compute the cost. And so to compute the cost, we take our list of crabs' position, our potential position for them to come all together, and then we sum. We start with cost 0, and then for all the number in the positions of the crab, we take number minus position, we call it abs, because then we do the abstract, we call it abs because then we do the absolute value of it. So if it's less than 0, we multiply by minus 1, and again, this is probably something that should be in the untowel. And then we do tot plus equal fuel of dist equal abs. And this is going to use the caching, so that if we have already computed the cost for a certain distance, we don't recompute it again. And then in the main, we read our input, we make the list of all the numbers that we read from the input by splitting the input on the commas. And since the last one can have a new line, we just trim them all. Then we make the minimum position of the crab, the maximum position of the crab, and now we have the range that's telling us which is the best place for the crabs to come together. And then we just make the list of the costs. So for all I in the range from minimum to maximum, we add the cost of getting the crabs together in that position. And then we get the minimum cost, and that's the result of our puzzle. And if I were to press run here after a while, but still an acceptable time, my stupid algorithm will still produce this result. That is the correct value for my day 7. So this is all for the first week of Advent of Code, and as you can see, in 21 hours there is going to be the next puzzle, and I have a long video to edit now. So, are you trying Advent of Code? What do you think about my solutions? Do you want to comment and explain why my code was terrible and what would have been a much better 42 solution? Would you like to try Advent of Code in 42 with me for the next week and post me your solutions and we can discuss together what could have been the best way? So, if you like this video, please like, subscribe, and come back for the next time. See you!